Thank you for attending this meetup on AI for Good. There was some brief. We stopped doing it for a couple of months. Like all had a very busy schedule. So we're going to resume with this meetup today and one in a couple of weeks. So today I'd like to talk and discuss with you towards the end of the presentation about how close we are to AGI, artificial general intelligence. Right? So it's a topic that some people like to discuss and some other people don't like to discuss, and we'll try to explain why. Okay. So first we have to define what is AGI, artificial general intelligence. So first, general intelligence. That's the two terms, general and intelligence. So intelligence is, I think this is well understood, ability to acquire and apply knowledge and skills. General intelligence is in contrast with neurointelligence. So general means that you can do it across like many domains, and we'll see later that there's some kind of common factor among these in intelligence. Neurointelligence is the ability to acquire and apply knowledge and skills in a specialized domain, right? So we call NI, or specialized intelligence, or specific intelligence. GI, general intelligence, the ability to acquire and apply knowledge and skills across many domains, right? So then when we move to machines, ANI, so the ability of a machine, right, to do the same. So ability of a machine to acquire and apply knowledge and skills in a specialized domain. And AGI is the ability of a machine to do the same thing, but across many domains. But there's something a bit extra with AGI is that when we apply knowledge, it means that we don't expect the machine to just memorize facts or data, right? So there's some capacity to generalization, right? So for instance, if I learn addition, arithmetic, I should be able to apply arithmetic to any numbers, not only the numbers that I have seen in my homeworks or in the past, right? So you have to be able to generalize. And it's quite important for, if a computer just memorizes facts and, regurgitate these facts, it's not AI or AGI. Okay. Short history of AI. I won't go over all the steps, but you should be familiar with that. The idea of AI, in fact, maybe studied in. You can even go as far as maybe the Greeks or even before that. But the modern like AI maybe studied like before like in the 1940s with the British mathematician Alan Turing, who published his paper Computing Machinery and Intelligence, where he suggested the Turing test, and we'll go over that. In the 1950s, there's a very famous workshop at Dartmouth when John McCarthy and his colleagues wanted to do AI research, and they coined the term artificial intelligence. So moving forward, 1960s, the first like a chess-playing computer program was developed. Right? So it was not like couldn't like beat like humans yet, but it could still play. The game of checkers too. In the 1970s, the first AI winter. So in fact, they were very ambitious. I think that people from the Dartmouth workshop, they thought that they could develop AI within a few years, right? And in fact, in the 70s, they were not there yet. And probably a limitation was the limitation of computing power, and the people who financed this research got disillusioned, right? So the funding for AI research declined. So well, we don't see any like tangible results. In the 1970s, there was some interest in expert systems, where we could like solve very specific problems within the limited domains, and it works somehow in some very specific domains, but it's very narrow. Second AI winter started with the financial market crash of 1987, And there was a market for specialized AI hardware that collapsed. There was no demand, and expert systems showed their limitation. But the field recovered. Then there was a reverse in AI in the 1990s up to now. So computers were becoming more powerful. 1997, Deep Blue, the IBM chess computer, defeated Garry Kasparov, right, the world chess champion at the time. So people got noticed that there's machines could be better than humans in some domain. In 2000s, they started to do research in deep learning. In 2010, there are a lot of progress made, especially in computer vision, facial recognition, and so on. They did research in Bell Labs on recognizing handwritten checks, for instance, or addresses on letters for the post office. 2016, maybe like this is really the modern era. DeepMind's AlphaGo defeated the Go champion Lee Sedol by 4-1. So at the time, so 97 computer could beat someone in chess, but people believed that Go is so complex, there's so many combinations that this was not possible. So it was really a shock, I think, for the community that a computer program could beat a Go champion. Then in the 2020s, they started to have a very good large language models, like OpenAI's GPTs, series of GPTs, GPT-2, GPT-3, now it's GPT-4, with a technology based on transformers. It was created in 2017, or even a bit before. 2022, so you probably all were witness of this when ChatGPT was introduced to everyone. It was available for free. It's the fastest growing consumer software application in history, with more than 100 million users. Right? And now, just recently, a few weeks ago, GPT-4o, or Omnium, from OpenAI, was released with impressive capabilities across text, voice, and vision, and with interactive personality. So current state of AI, so I mentioned GPT-4o, OpenAI, but Google, Mistral, Meta, they all have their large language models, and the competition is very fierce. And every week, they have new release, new research, new techniques, and so on. So it's advancing at a very rapid pace. So here, just like you might have seen it, is a short video on GPT-4o. So let me play it for you.
I want to introduce you to somebody. Hello there, cute. What's your name, Sluffball? This is Bowser. Well, hello, Bowser. Why, look at that focus. Did you cause a serious business for Bowser?
So you see that you notice that the GPT-4o, I don't know if actually it has a name. So saw the dog, recognized the ball, right, the color, and was interacting with the user.
I want to introduce you to somebody.
So let's do a small detour on general intelligence. Right? So people have been interested in general intelligence for forever, and even before the era of computers. And why we talk about this? Because we could think that maybe you should assess machines like we assess humans, right? Someone is intelligent or not. Maybe you should use the same test to see if a machine is intelligent or not. So behind this testing of general intelligence, we have what they call the G factor. It was introduced by a statistician called Charles Spearman. And Spearman is also a very famous statistician. You have what they call a Spearman rank correlation. So it was also due to him. So he noticed that across a cognitive task, there was a common factors that he calls a G factor. So in modern days, you could use a principal component analysis to isolate these factors across cognitive tasks. And this explains roughly 50% of variation across individuals. So there's something in common, right? So there's some G factor or smart factor that seems to make someone smart across all the tasks, right? Not 100%, it's not 100% correlation, but if someone has a high G factor, it tends to, on average, do better across all the cognitive tasks. If your G factor was low, you tend to do poorly across all the tasks, right? Then there was some refinements. There's something that's called the cattle horn carol theory. Well, they also start with the G factor, but they put it at the top. Right? So this is the command factor. Then it's you should imagine, you should look at it as a tree. Then it's on roots, if you see, or branches. Then below the G factor, you have a 10 broad abilities. And below these 10 broad abilities, you have 70 narrow abilities. Right? So the broad abilities comprehension and knowledge. So how much a person has learned or know and can communicate the knowledge. Fluid reasoning, can a person reason in new situations? The third one is quantitative knowledge, right? Can they do understand and use quantitative methods? Can they add numbers and so on? Reading and writing ability, short-term memory. Does someone like that person like remembers fact, recent facts, long-term storage and retrieval. So it's like long-term facts, and can they remember and retrieve, the memories? Visual processing, can that person perceive, analyze, synthesize, and think with visual patterns, right? And remember visual representations. Sound, auditory processing, and processing speed too, right? So are you fast at solving puzzles or at thinking? Then below that you have like 17 neural abilities. So they break down these broad abilities. It could be like mathematical knowledge, achievements, reading, decoding, verbal information, etc., etc. So it would make sense to try to assess machines based on these the same kind of abilities. And in fact, the IQ test is really based on these on trying to measure these abilities. Okay. ANI is artificial neural intelligence. So as we said in the intro, is the ability of a machine to acquire and apply knowledge and skills in a specialized domain. So we mentioned the game of chess and Go. So I talked to you. We talked about AlphaGo. The next iteration was AlphaZero. That was also able to play across like 3 games, board games: chess, shogi, and Go. And they could beat humans. Not only humans, they saw the state-of-the-art like computer programs at the time, right? So in chess, it's a software called Stockfish. And AlphaZero was able to beat AlphaGo. The particularity of AlphaZero is that AlphaZero was trained. So AlphaGo was trained on by at least at the beginning by imitation. They look at it was fed with like human played games of Go, and try to learn from it. AlphaZero was not trained by imitation. It's not trained to play against itself, right? So it will train it will play against itself. Each time it will win, it will learn some pattern and then recalibrate its neural networks and then play again, right? And then in just a few days, it'll get like superhuman performance. Right? So it's a bit different than what we are doing today with large language models, but it's so we have artificial neural intelligence in some neural domains. So this kind of games, computer games, usually now AI is doing pretty well. Have like superhuman abilities. In some also neural domain, healthcare, medical imaging, virtual assistants, so they can do on par or roughly on par, sometimes better than humans. And in finance for fraud detection, and algorithmic trading, etc. Artificial general intelligence. So how can we measure it? So we can do like ask the ChatGPT or AI system to take an IQ test. Right? So some people have tried to do it. So I think not everything in IQ test is verbal. So they take the verbal component of the IQ test. They can do vocabulary, comprehension, and so on. And some researchers find an IQ test of 155, right? So it's like pretty good, like top superior to 99.9%. I think the average IQ test in the world is probably like 100. Because IQs are correlated with income and wealth, so richer countries tend to have a higher, not always, but it's roughly like increasing with income. It makes sense, right? You are very poor, and you have like other preoccupation, and you might not have like many years of schooling too. So there's correlation to that. But 155 is a very impressive number, right? But there's also other tests, and I'm going to talk about that. So the Turing test, right? So the Turing test was proposed by Alan Turing. So you might have seen the movie, The Imitation Game, with Benedict Cumberbatch. And I highly recommend this movie. So talk about this imitation game. So the idea is to try to have a text-based conversation with a human and a machine, trying to guess if it is a human or a machine, right? So if you cannot tell the difference, then we say that the machine is as smart as a human, or that. So it makes sense. It can make sense, right? We say, okay, we cannot distinguish between a human and machine. That is, well, that machine sounds as intelligent as human, right? But the test has been criticized. They say that maybe it's just mean that the machine can fool the human and say, you can pass for a human, but you're not really intelligent, right? And there was a British, I think it was a philosopher, John Searle. He had an analogy of a Chinese room where like a machine which was just like doing, or they were just using. So I think it was like to see if a machine could to understand Chinese, right? And so in fact, they were just like using a lookup table. So I look at the Chinese message, look at lookup table, get the English translation, and just answer with the English translation. So the machine doesn't understand anything. Just look at the lookup tables, right? So just like pattern recognition, and so there's no real understanding. So to say that maybe that test is not relevant, but still is an interesting test. And for many years, in fact, many machines couldn't pass the Turing test. I think up to 2020. I think there was a Lopno prize. I think that so some maybe wealthy person like gave there's an annual prize to the machine that will pass the Turing test. I think no program has won it up to 2000. I think they discontinued the test in 2020. So here, this is like a research that has been done. So recently, like in May, so last month in May 2024. So they try to see. So they try to do it as an experiment. They test like three systems: GPT-4. So this is the GPT 3.5. So this is the previous iteration of GPT. On ELIZA. So ELIZA was a system, I don't know if it was developed in the 70s or something like that. It's a chatbot that's not very smart, but could fool people, right? It could fool people. It was smart. It was programmed in such a way that it will sounded very, very human, right? For instance, if the system didn't know the answer, it would like answer with a joke or something like that. But it was not. There's no AI or anything behind it, right? So they use also ELIZA as a benchmark, and they select participants, the 500 participants, and make them like chat with this system, and also with humans, right? And what they find is that humans couldn't like distinguish between GPT-4 and humans, right? So the GPT-4 like could be like pass the GPT-4 and 3.5 could pass the Turing test, right? So they couldn't tell the difference, but they could tell that ELIZA was not humans, right? And humans, when they were humans, people were quite accurate to say that they were talking to humans. Okay. So AGI? So you'll see this is a very fascinating topic. So some researchers from Google. So this is like October 2023. wrote a piece, an article that magazine Noema said AGI is already here, right? So it's here, it's among us, right? We met AGI, right? And these are not like, these are serious people, right? Peter Norvig wrote the standard test book on AI with his colleague Stuart Russell on artificial intelligence. So it's really like, he's an expert in AI. Blaise Aguirre Arcas, he's also a very well-known AI researcher, I think also at Google. And they both believe that AGI is here, right? Has been achieved in 2023, right? We are in 2024. So what they argue that current AI models, ChatGPT and Bard is a language model from Google, can perform many tasks that humans can, including answering questions, writing different kinds of creative content, translating languages. So they're not narrowly trained for specific tasks, and they can be instructed to perform well on new ones, what they call by using in-context learning. So in-context learning means that it's a prompt that when you interact with ChatGPT, so you can tell context, can give like say describe exactly what you want, right? And ChatGPT will understand what you want, right? So you can say, you can give few examples in the style of this, prove the Pythagorean theorem in the style of Shakespeare sonnet, and these kind of things, right? And you can do it, right? You can do it most of the time. So they argue that should be a shift in how we view general intelligence, and maybe focus on measurable competence rather than unverified human-like qualities like consciousness, because, well, I didn't put it here, but if you read the article, some people say, yeah, it's not conscious, it's not really human, and so on. But they say, well, maybe it doesn't matter, if it's how they come up with the answers and how they're thinking. It's not going to think like a humans, right? It's probably not conscious, right? And we don't need to have a machine to be conscious like a human to reach AGI. Right? This is what they argue. But this is that you'll see that it's not the common view. Okay. So Google also has published a paper. I put a link where they try to have some objective measure measures to measure the progress on the path to AGI. That's published in November 2023. And you might have seen something like this for cars, right? You have like different levels of self-driving. So here it's like different levels of performance. So it goes from level 0, no AI, right? So different rows to level 5, superhuman, right? So superhuman means you outperform 100% of humans, right? And then you have the different steps: emerging, competent, expert, virtuoso, right? Virtuoso and superhuman, the bar is very high. And then you have two categories of two levels of generality, narrow and general, right? So that's why we talk about narrow intelligence and general intelligence. And so depending on the field, right, we have reached narrow AI, right? Like we've seen for AlphaGo and Deep Blue. For instance, we had you see like on the top, at the bottom, in the middle case, superhuman narrow AI for AlphaFold. So it's like AlphaFold for protein folding, AlphaZero and Stockfish for chess. So it means that human chess players cannot beat computers today, right? It becomes a problem because now it's easy to cheat in chess, right? People use computers to cheat, right? Or when people play too well, they suspect that they use computers to cheat, right? So it's becoming a big problem. It's because now the machines are much better than humans. For general intelligence, so it starts from general non-AI to ASI, right? So at the bottom right corner, ASI, artificial superintelligence. And you see that according to Google, so this was done November 2023, Google think that we haven't achieved AGI, the level 2 to 5. Okay, so you have emerging, right, for the level 1, better than an unskilled human, and but we are not there yet for for AGI to be at least better than 50%, 50 percentile of skilled adults. Right? Here, this is like, so this, I don't think they have updated that studies for GPT-4o, but this is from the GPT-4 technical reports. This has been updated in March, but I don't know if that table has been updated. So this is the performance of GPT-4 across different academic and professional exams. So you might have seen it because it was the first version was published earlier in 2023. But you see that in the bar exam, it has a score like 228 out of 400, so 90th percentile, right? If I were to take the bar exam, I'm not a lawyer, I probably score first percentile or something like that, right? Not even 50th percentile, right? LSAT, right? LSAT, the same thing. These things are these tests. If you don't study for them, you take random humans, you probably score very poorly, right? SAT math and so on. So do you see these numbers are pretty good. AP, right, the advanced placement test that you take in high school, a senior year in high school, is doing pretty well too. Right? You see IP statistics, they're between 85th and 100th percentile, US history, 89th percentile to 100 percentiles, etc. Right? Interestingly, you see that in lead for lead code is for coding. At the time, it was doing quite poorly for coding. So usually now, like in modern like AI research, the researchers use benchmarks, well-accepted benchmarks that are like public benchmarks, to showcase the performance of their models and compare their models to other existing models. Right. So here I won't go over all the tests. This is a report from when GPT-4o was released. GPT-4o is the GPT that was talking on the phone, right, and looking at the dog on the ball, right? So it's this is the purple curve, right, the bar, and you see like it tends to be equivalent most of the time, like higher on par with the existing models, right? And I'll just go over two tests, two benchmarks. The first one is MMLU. You'll see, you read even in the press, you talk about AI system, they talk about these benchmarks. This is what they call massive multitask language understanding benchmark. It's a collection of multiple choice questions from diverse subjects that test a large language model's ability to understand and solve problems across various domains. Okay. Then you have a GPQA, graduate level Google Proof Q&A benchmark. It's called Google Proof because you cannot get the answer by just Googling. You're just doing Google, right? The answer, you have to work on the answer. For humans, it might take, I think when they did it, they designed these questions, it takes like 30 minutes for humans to find the answer. Right? So you cannot just Google it to get the answer. Right? So it's a hard benchmark. So it's a challenging data set to design to evaluate the capabilities of large language models. And it consists of 448 multiple choice questions in the domain of biology, physics, and chemistry. And then you have the rest of other tests. Other benchmarks. So here, this is like something called like a Helm. So this is from Stanford. So it's the holistic evaluation of language models. So it's what they call an abstract taxonomy. So classification of a concrete implementation of scenarios and metrics to evaluate language models. Right? So you might have something externals, because in the previous, for instance, in the report from the previous slide, it was tested by the researchers who developed the models, right? So I mean, probably they did serious work and so on, but maybe it's better to have like a third party to evaluate these models and have something public and transparent, to make sure that all these models are comparable and so on. So Stanford tried to do that with the Helm leaderboard. So they have scenarios on metrics. Metrics is how they are doing it, and the scenarios are the different tests. And if you go to their website, it's just this is the leaderboard. And you had so on the first row, you see the different models. Actually, at the top, GPT-4, the GPT models tends to perform the best. And then you have all kind of models below. Some models are a bit strange that we haven't heard them. So you have Chinese models and so on. The reasons that many of these, some of the models are open source. So you are free to copy these models and improve them at the margin, right? So sometimes people take an existing models, they improve it, and then they republish it under another name, right? So that's what's happening. But well-known models are Mistral, Anthropic, Claude, Palm, Llama from Meta. And then the different columns, you see the different benchmark, right? You recognize the MMLU. So it's what, 1, 2, 3, 4, 5, 6. The six benchmark, MMLU, and you have the math benchmark, MedQA towards the end is for medicine, etc. Okay, and here they describe what are the different benchmarks. So you can go on the website; it's accessible to all. Okay. So this I go over this. I'm going to skip this. This is what another benchmark, Truthful QA. So this is 118 questions that goes over 38 categories. It's available on GitHub, and they say how it performs. So at the beginning, it was a very difficult benchmarks to beat, right? And but now they start to beat it. One issue is that this benchmark shouldn't be in the training data of these models, right? So researchers have to make sure that the model didn't use this test, right? Because the model was trained on the question and answers, of course, it's going to score very high, right? So they have to make sure it's not since it is on GitHub and probably available, it can be available to these large language models. So when they do the test, right, they have to make sure that it was not trained on these benchmarks. I need to skip this. This is like an interesting benchmark. So it's a bit. This is by a researcher at Google. So this is a paper that he's tried to criticize the other benchmark and try to introduce a new benchmark. But to be frank, reading his paper is really testing your own IQ, but I think it's a bit difficult to read. So it's kind of formalized and so on. It's a bit of a math paper, so I mean, we can have a look and a measure. So it doesn't have much impact, but I find it's quite interesting. So basically, these are, I think, he creates a series of tests. So these are visual tests, but typically you have to find what is the missing piece, the missing graph. So try to so you see that when you do, if you have done the IQ test, standard Binet test, Mensa society test, and this kind of thing, I think they do a lot of this kind of pattern. Try to complete the pattern, and because you can create like many kind of games like that, but it's unlikely that these models have seen these games before, right? So these are the games that this was created especially for this benchmark, abstraction reasoning corpus. Okay. Okay, so these are kind of so when you read like new models, usually they talk to you about benchmarks, but we can talk to the researchers themselves, right? They express themselves and they give their opinions. And some of them are very well respected, so they are usually the top scientists in their fields. So you see there are a lot of disagreement, right? There's no consensus. So we saw earlier that Peter Norvig his colleague thought that AGI was here, but not everybody agrees. So Yann LeCun, he's French. He's a chief AI scientist at Meta. He's a Turing Award winner. The Turing Award is like the Nobel Prize for computer science. So he thinks that AGI doesn't make sense. Okay, so you see, this is like something he posted on LinkedIn just 4 months ago. So say every intelligence is specialized, including human intelligence. Intelligence is a collection of skills and the ability to acquire new ones quickly. Nice, consistent with what we said before. He said it cannot be measured with a scalar quantity by a number. no intelligence can be even close to general, which is why. So he said that. So it seemed that he seemed to say that even like people don't have general intelligence. I'm not sure how you should read it, but so he said AGI makes no sense. I don't know. It's what they think. So I don't know if I agree with him. So it's there's no questions that machines will eventually equal and surpass human intelligence in all domains. But even those systems will not have general intelligence for any reasonable definition of the word general, right? So I think that so it'd be a collection of narrow intelligence, specialized domains. And in each domain, we will achieve superhuman intelligence, beat the machines. But he thinks that we won't be able to have like an AGI. But sometimes he's doing research on it, so I don't know, so I don't know what's his view. So second Turing Award winner, in fact, they won it at the same times. So so Jeff Hinton is he's more adamant that we are close to AGI, but he's in fact very concerned about it, right? So when he says that 20 years ago, so people who have happily agreed that the system with the ability of GPT-4 or Google's Gemini had achieved general intelligence comparable to that of humans, right? 20 years ago, right? And being able to answer more or less any questions in a sensible way would have passed the test. But now that AI can do it, people want to change the test, right? You move the goalpost, right? It's human nature, or we say, no, whatever AI can do, it's not AI anymore, right? It's kind of the same idea. Joshua Benjo, this is the third fellow who won the Turing Award that year with Yann LeCun and Geoff Hinton. So I won't read. So this from his blog. So I won't read the whole story, but he said that. So he's a top researcher, right? He's been working on this subject a lot. And then you see his last paragraph. So that he talks about system 1 and system 2 abilities. So this based on the work of Daniel Kahneman. He's like a psychologist who won the Nobel Prize in Economics. I talk about system 1 or system 2 thinking. System 1 is kind of quick, intuitive thinking when you make like spot decisions, and system 2 is more deliberative thinking, where you have to think carefully. It's more like the careful thinking, system 2 abilities. So what he says, since I've been working for over 2 years on a new approach to train large neural networks that could potentially bridge the system 2 gap. So it was his research agenda, right? Try to close the system 2 gap. It started to dawn on me that my previous estimates of when human-level AI will be reached needed to be radically changed. Instead of decades to centuries, I now see it as 5 to 20 years with 90% confidence. 5 to 20 years, right? So it's written this last year, right? So 5 to 20 years is 90% confidence. Andrew Ng, so he's more on the side of so he doesn't want to speculate too much on AGI. I think people who are more like on the business side of things, because he used to be a Stanford professor, but now he's leading different startups and so on. I think they don't feel very comfortable sometimes talking about AGI. So he just say, oh, it might happen, but it will happen like you take numerous steps, step-by-step improvements. It's not that suddenly we'll get AGI at your doorstep. Right? Demis Hassabis, so he's one of the smartest guy in AI, the CEO of Google DeepMind, right? The team that did AlphaGo, AlphaZero, AlphaFold, or protein folding. He got like a prize, like almost like a Nobel Prize for his research on protein folding for AlphaFold, I think recently. So what he says, so when he's asked, about AGI, so what he says, I don't have a prescribed specific numbers to it, right? It's like when it's going to come, right? AGI. I think there's so many unknowns and uncertainties. So human ingenuity and endeavor comes up with surprises all the time. So that could meaningfully move the timelines. I will say that when we started DeepMind back in 2010, we thought of it as a 20-year project. Right? So it means 2030. And I think we are on track, actually, which is kind of amazing for 20-year projects, because usually they are always 20 years away. There's the joke about whatever, quantum, AI, take your pick. But I think we are on track, right? So I wouldn't be surprised if we had AGI-like systems within the next decade, right? So he said that in 2024. So within the next decade, and he said he's on track for 20 years. So maybe 2030 is not irrealistic. Shane Legg, so he's very interesting fellow. He's so chief AGI scientist. So he's the AGI guy at Google. No, so what he says, so he says that there's a 50% chance that we have AGI by 2028. Right, this is in 4 years from now. So he says 50% chance. Okay, so he's hedging a little bit, but it can come. He saw someone who wrote I think his dissertation was on universal intelligence. You can find it on the internet. So he has been working on it, I think, since 2006 or 2007, right? Jason Huang, so he's more a businessman. So he's the person who provides the weapons, right, to the AI war. So he produced these like famous GPUs, graphical processing units, right, processing units to do AI. So he also doesn't feel very comfortable talking to AGI, right? But when you ask him what he says, we specified AGI to be something very specific, right? So he said we define it as a set of tests. Tests, so you can think of like measure of narrow AI, where software program can do very well, or maybe 8% better than most people. I believe we will get there within 5 years. So the test suggests they get bar exams, that's what you saw before, logic tests, economic tests, so like in narrow fields, right? So they say like the battery of fields that we agree on, right? The benchmark we've seen before. And if AI does 8% better than humans, you think that we have AGI. It makes sense. You have to define exactly what it is, right? If it's too vague, then you keep moving goalposts, and we'll never reach an AGI. Okay. So Sam Altman, so he's really at the core of all this like AI revolution, right? He's the CEO for OpenAI. So his company has released ChatGPT, GPT-4, and so on. So he doesn't give like he's smart, so he doesn't give like numbers but he said that we'll get AGI. So AGI is basically, so I read what he says, basically the equivalent of median human that you could hire as a coworker. So you can hire the AI as a coworker, and that coworker could do anything that you'd be happy with a remote coworker, right, that you hire from another place, and doing just behind the computer. Which includes learning how to go to be a doctor, learning how to go be a competent coder, etc. Right? So say if you have that, right, you feel comfortable instead of hiring a remote coder, you're going to hire an AGI, or can get a subscription on OpenAI to get an AGI coder, is when we have reached AGI. Right? Dario Amodei, he's the CEO of Anthropic. So Anthropic is a company that does cloud. So the differentiation is that they want to do responsible AI. Right? So they say they want to be more careful about how they develop their AI models. So they have this model called Claude, and so he thinks that we are not very far. It could happen in 2 or 3 years. He said that in last summer. So 2 to 3 years, 2026. So like 2-3 years, right? He's someone who worked, I think, for Google before. So these are just a sample of like well-known people that that you can find on the internet or listen to web podcasts and so on. You listen to their opinions. So some researchers have been surveyed. This is like some research from a research organization called AI Impact. So they've been surveying 2,800 AI specialists, researchers in AI, and so they expect significant progress in the next decade, right? But what is interesting? So the graph, you see that we talk about HLMI, so high-level machine intelligence, right? So so when AI might outperform humans in all tasks, right? So could we say that's the notion of AGI or superhuman AGI. So they think that there'll be a 50% chance of HLMI by 2047, so 20 years from now, right? And before this is done for 2020, forecast done in 2023, 2022, 2000, it was forecast for 2060. Right? So from 2060, we move to 2047. Next year, I mean, we can just extrapolate. Maybe they'll see that is like 2037. I wouldn't be surprised. Okay, there are still problems with AGI or like AI, right? So I go briefly on two examples. You might have heard of Google Gemini, but it was the first release. Google Gemini is like the GPT-4 of Google, right? So so they released. So you could using the Gemini system, you can enter a sentence, a prompt, and get a picture back, right? And here you see that if you say draw me a German soldier, right, and it will draw like soldiers that have like Asian features, that are female, woman, or they are like black soldiers. So it shocked a lot of people, right? And you know, of course, people know where it comes from, right? That Google probably wanted to add like a diversity, and to have stereotype, right? I mean, it started with a good intention. That for example, you say, draw me a doctor, because historically, maybe in pictures, you have more pictures of male doctors than female doctors. Then you ask Google, draw me a doctor. Most of the time, be a male doctor, right? But you might want to have like a female woman doctors too, and there's no reason why. So maybe they kind of force it to increase the representation of a woman, but same thing for minorities, right? So most likely, a doctor will be a white male doctor, right? So they'll have more representation to have maybe people of color, right? But in that specific kind, you said that the results are very absurd, right? So they had to work on it. So you see that even if it close the AGI, there's some issues. More recently, right? So this has happened, and they got some heartburn, right? But they had so you might have experienced this yourself. So Google has has tried to revamp the Google search engine by using AI in search, right? One of the motivation is that they feel the heat, right, in the competition in search. So search, it is, as you know, it is the cache engine of Google, right? I mean, they do money in cloud and so on, but it's really like their lead product, right, in search advertising, right? So if someone comes up with a search engine based on AI, they would do better than Google, give better answer, and some people will switch to that new system. But there's a company called Perplexity that tends to start to be popular and use AI for search, right? So they see the competitive threat, so they were like very eager to try to switch to AI. But then when you do that, then you have there can be some problems, and because so many people use Google, I use Google. Many of you use Google. So after the millions and millions of search done every day, you often find like anomalies and so on. So here you have examples of. You can put glue in a pizza. So I don't remember the prompt exactly, but you had to make the pizza stick together or something like that, and they said to suggest to put glue, right? Or sometimes they suggest to put rocks in your menu and so on. And you see that that it was very recent, just like a few weeks ago. So Google had to apologize and said that they try to improve the system and remove nonsensical results and so on. One reason why it's coming from is that they are combining. So it's not pure hallucination. So hallucination is that like something you said that's something that it creates something that doesn't exist, right? In fact, this kind of recipes, putting glue in a pizza, rocks in a recipe, they do exist on the internet as jokes or as at pranks or these kind of things, and somehow the Google will like search, retrieve these results, and use AI on top of it to try to clean up or format the answer, right? So it's not entirely Google's fault, right? So some random teenager suggested a way to put glue in a pizza, and they retrieve the results because maybe not many people talk about glue in a pizza, right? So you search glue in a pizza, maybe you find only one Reddit post talking about it. They say, okay, the number one must be the right one. And then they format the answer and they give it to you. So but they realize the mistake. So maybe it has to, so they have to check that it's not complete nonsense. Okay, so we are towards the end. So how to reach so maybe we think we have AGI today, this imperfect AGI, and how to do better AGI. I won't go. Maybe I'll give another talk, so we can invite people to give talks about this. So there are ways that people think they can improve on AI. Scaling laws just means that we spend more money on data and compute, we'll get there, right? The machines tend to improve, right? So, but just by themselves, at the margin, improve a bit of the technique of how you train the neural networks and so on, you will get there, right? Just scaling. Right? It works. So just buy more GPUs, hundreds of thousands of GPUs, spend hundreds of millions of dollars to train their models, as they're doing it right now for GPT-5, the next iteration. They spend a lot of money on that, maybe on slightly better models, and they think that it'll be much smarter than GPT-4. It's very likely that, I mean, if we just extrapolate from what we have seen before, from GPT-2, 3, and 4, it's possible that GPT-5 would be like very smart. Multimodal AI means that in the past, so now they use a lot of text on the internet, Wikipedia, Reddit, and so on. But now the idea is to sort of train on images and videos and so on. People use YouTube, but I don't think it's legal to do that. Better AI models, so people say we have better mousetraps. So people believe that you need to build robots. Maybe AI needs to interact with the environment and learn from the environment to really become smart. Agentic AI means that you can have teams of autonomous AI working together, and then maybe as a team they can come up with be better than a single AI, and can do a hybrid system of AI, deep learning AI, combined with the old, like what they call good old-fashioned AI, when you like symbolic AI, maybe we could get there. So this is something that I think companies are investing in that, maybe not enough. Academics are very interested in this area. Is the field of ethical AI. So we call here Ether AGI. So I ask Google Gemini to come up with a good acronym. They come up with this Ether. So for align, AGI, ethical, trustworthy, human-centered, explainable, and reliable. Right. So today you might have AGI, right? At the beginning can do many things, but it made mistakes. So that's not it's not reliable. Sometimes it's not ethical. It's not trustworthy, right? Sometimes the results you still have to check them, right? You always have to double check what an AI gives you as an answer. It's not necessarily human-centered. It's not sometimes always explainable. So sometimes we don't know what they come up with the answer. So another thing is missing, right? To get the Ether AGI, this is what ideally what we like to have, right? So maybe you have AGI, but non-Ether AGI, right? But it's still lacking. So here there's a comparison, maybe to make food for thoughts. Here is so you could talk about Ether commercial flights, right? So 1903, right? We had the first flight, right? Using an engine, right? The Wright brothers had the first flight with an engine. It lasted only 12 seconds. It traveled 120 feet and reached a top speed of 6.8 miles per hour. But it was very short. But it was the first flight. It said the first flight is 1903. It flew only for 12 seconds, right? So it's not really not that very long. But still, we say it's so. I kind of sympathize with the view that AGI is already here, that we have seen it. And maybe in history books later on, we say, okay, 2022. ChatGPT came out, it was the first AGI, right? So very imperfect, like the first plane that the Wright brothers came up with is very imperfect. They could fly only 12 seconds. But still, we said the first flight was done in 1903. Then first commercial flight came 11 years after, in 1914, in Florida, from St. Petersburg to Tampa. That's the first commercial flight. But here again, so it flew, right? There was one paying passenger. At the time, it was seriously dangerous to fly. Many people died, and in fact, the pilot of this plane died. Many years after. I think he died in France, in a plane crash, right? So there was and notice, right? This plane, there's no cover, right? There's no protection, so so it was extremely dangerous to fly. And so we are probably like there's a similar situation for AI or AGI. And now today, of course, you have Boeing now. But that what is interesting. You remember with the Ether, right? Aligned, ethical, trustworthy, and so on. Right? So Boeing had also some issue with one of it, not this plane, but another plane that maybe the construction was not totally trustworthy. Some people who worry about climate change, they said airlines emit a lot of carbon emission and so on. So maybe they're not totally aligned with humanity and this kind of thing. So even with you could say like more than more than 1 century after flight was invented, we are not totally the airline industry is not totally aligned, right? So now I'm going to conclude. So we have reached artificial neurointelligence in some domains. So that's I think we all agree. Many measures of AGI. You have some people agree that some people think that I kind to sympathize that we already have AGI, but imperfect AGI. AGI doesn't mean that it's perfect, and AGI doesn't mean that it's superhuman, right? It just means that you can do a lot of stuff, without no limited number of explanation, and it's like general enough. Right? You're not like you can only play chess, you can only draw pictures and so on, but you can do many things. So maybe we're already there, right? But there are many paths towards a better AGI, and I think many researchers are doing that. AI can be unsafe without being AGI, right? So if people are concerned about AI, we should be concerned now. You don't have to wait for AGI to be concerned, right? So safety, risk, and so on, people need to work on it today, and many people are doing it today. But commercial companies maybe are less they want to do it responsibly, but they work for shareholders and so on. So maybe they put more resources on building the next GPT rather than to do ethical research. But it's a balance between the two, right? So I think that's it. So I think it's still ongoing things, and I think I hope that this presentation helps you to see that the state of the art today, and help you read the press and follow the research. So I need to stop sharing my screen now. I need to stop the recording, and we'll